Okay, so we're going to get into a little bit more about the cross product today. We're going to start with a bit of a proposition. And the proposition that we're going to say is that if A and B are vectors in R3, then A cross B is perpendicular to A, and A cross B is perpendicular or orthogonal to B. It's better to say orthogonal here. We're going to prove this. It's pretty straightforward. If I take A cross B, that is defined as A2B3 minus A3B2, A3B1 minus A1B3, and A1B2 minus A2B1. Now, if I take and dot that with A cross B, right, so A with A cross B, I'm going to get A1, A2, B3 minus A1, A3, B2. Oops. That should not be a bracket, right? Because this should be a scalar. So it's that plus A2, A3, B1 minus A2, A1, B3, and then plus A3, A1, B2 minus A3, A2, B1. All right, so if I carefully look here, I have A1, A2, B3. This is A1, A2, B3. They cancel. A1, A3, B2 is the same as A3, A1, B2. They cancel. A2, A3, B1, A3, A2, B1. They cancel. So that means this is 0. Which means that A cross B is orthogonal to A. And a similar argument can be made for is orthogonal to B. I'm not going to go through all that because it's going to be the exact same proof, except for when things fall out, it's because you're dotting with B. Okay, so this also brings us to something that's going to be called the law of sines, which we will read as A, B in R3, and that if theta is measure between A and B, so again, I have the situation where I have the A vector, the B vector with a common endpoint or common initial point. This is going to be theta. Then there's a relationship between the cross product and this, and it's that if I have A cross B, this is equal to the magnitude of A times the magnitude of B times sine theta. Okay, so proof for this is in notes. I am not going to walk through the proof step by step here because it is tedious and not much fun. My suggestion to you would be to see if you can kind of follow it, and if you have trouble with something that's in there, come on in and bring it in class and we'll take a look at it. I would, however, advise that you put a star next to that proof in your notes, because at some point in your life, you might find yourself in a math class where someone asks you to prove this, and you'll have that proof available as a resource, and then you'll look wicked smart. All right, so I'm going to let that one go, but the proof is there in your notes. Now, there is a corollary to this that is fairly useful. So a little theorem that follows from the law of sines says that if A and B are both in R3 such that neither of them is the zero vector, then A cross B is the zero vector if and only if A and B have the same or opposite directions. So either A and B are moving in the same direction, or A and B are moving in opposite directions. In these cases, A cross B is 0. And this isn't biconditional, so you can go both ways here. So we have to prove this both ways. All right, so we're actually going to show that that's true and that it follows from the law of sines. Okay, so the proof of this one, we start with that A cross B is the zero vector. Okay, so going both ways, this implies that A B sine theta is 0. Well, why is this? Because this is the law of sines. And if I take the magnitude of this thing, then I have to get the 0. I have to get 0, which means that if this is 0, its magnitude would have to be, or it would have to be, if the magnitude of the cross product is 0, then it has to be the 0 vector, because the only thing that has a magnitude of 0 is the 0 vector. Okay, since A and B are not the 0 vector, and the only way that I can get a magnitude of 0 is if it is the 0 vector, this means that the sine of theta is 0. This, since we're dealing with an angle that is from 0 to pi, implies that either theta is 0 or theta is pi, which means that A and B either have same or opposite direction. Okay, so briefly summarizing, we have that A cross B is orthogonal to A and orthogonal to B. We have that the magnitude of A cross B is equal to the magnitude of A times the magnitude of B times the sine of theta. And then we finally know that if neither A or B are the 0 vector, then A cross B will only yield the 0 vector if A and B are in the same direction or A and B are in opposite directions. And that's biconditional. So that's an if and only if. That's your summary for today.